Welcome to Team 537's Robo Recap for the week of January 9th through the 15th. I'm your host, Danny Callis. This week began with the kickoff event for the 2016 competition season. Teams from across southeastern Wisconsin traveled to Waukesha County Technical College to watch the first kickoff live as it went streaming simultaneously to events worldwide.
Welcome to the first robotics competition and the 2016 tournament challenge, First Stronghold. The Alliance quest is to breach the opponent's defenses, known as the Outer Works, weaken their tower with boulders, and capture it. The low bar in position 1 is permanent. The defense in position 3 changes periodically by audience selection. Opponents are savvy and will be strategically selecting the remaining 3 defenses to strengthen their outer works while in line for their next match. There are more than 10,000 possible field configurations. Robots start in the neutral zone and may have 1 boulder each. Additional boulders will be placed on the midline and in each castle. Alliances may assign a spy bot to start in their opponent's courtyard and a human player to occupy the spy station to signal intelligence about activities on the far side of the field to their castle. The first 15 seconds of the match, the robots are autonomous and may earn points by reaching their opponent's outer works, crossing defenses, and scoring boulders in goals. During the following 2-minute and 15-second teleoperated period, human drivers remotely control their robots. They retrieve boulders, overcome opponent defenses, and score boulders and goals from their opponent's courtyard. The first time a robot fully crosses a defense, some of the base lights will turn off, indicating that defense's strength is reduced. On the second crossing, all lights turn off, indicating that defense is considered damaged. Once any 4 of the 5 opponent defenses are considered damaged, the outer works are breached and the Alliance receives points. Human players deliver boulders to their secret passage through their castle wall. Alliances may have only 1 robot at a time in their own courtyard to defend their castle. As boulders are scored, the tower loses strength. Once enough boulders are scored in the opponent's tower, the opponent's flag will drop, indicating the tower has been weakened and can now be captured at the end of the match by surrounding it. During the last 20 seconds, robots may extend to reach the tower rungs and scale the tower for additional points. If an alliance captures their opponent's tower at the end of the match, their flag is raised and the alliance earns more points. The alliance with the highest score at the end of the match earns the win. Step into your castle, proudly raise your team standard, and face the challenge ahead at this year's first robotics competition, First Stronghold.
For team member Nick Zarling, this was his first kickoff event.
I think the game challenge is cool and interesting with everything that's going on in the challenge, but I also think it's complex with the defenses and how they change each round. Crossing the defenses will challenge our team the most because with the defenses, we don't exactly know for sure which defenses will be out there. The defenses would be the most challenging part.
I like it a lot. I think it's a lot more interesting than last year's in that there's a lot of things that you can do with it. I really like the strategy aspect of it because I've played a lot of those sort of games throughout my life. I think that this game really brings out like the strategy aspect of it. One thing that I don't like as much is that I wish there were more options for the defenses because I feel like it's just going to always turn into the same 4, but that's fine. That's just a small thing.
After learning about this year's game, Stronghold, Team 537 broke into groups and discussed the rules and strategy before moving to the WCTC gym to see the mock construction of the 2016 course for themselves. The mock course was available to all participating teams, courtesy of Team 537. As one of the few teams in the area to have a full course, select mentors and alumni of Team 537 were allowed to see plans for the 2016 course a few days early so they could build the mock-up, and were not allowed to reveal any parts of the game to anyone before the live kickoff. On Sunday, January 10th, select members of the team met at the Pauline Haas Public Library to analyze the game, design a competitive strategy, and work out the parameters of our design. The meeting gave students a chance to get away from the usual work setting of Hamilton High School and focus solely on the challenge ahead. Monday and Tuesday were all about taking ideas and turning them into something physical. Our design CDT is most crucial at this stage in the process. Austin Dalzin is our design lead.
The general process we use for designing parts starts with the brainstorming phase, where we come up with all the different ideas of mechanisms and wheels, drivetrains, anything that we'd want to use on our robot. And then we take those ideas, narrow them down into a list of ideas that we would actually want to test, and we take those and we prototype. We build models of the ideas in order to test and analyze them. Then we take our results from there, narrow our list down to one that we actually want to go with on the robot. And we take that and we go use computer-aided design software to design the parts that would actually make up those mechanisms on the robot. The most difficult part of the game challenge for design is definitely going to be trying to combine and incorporate different functions and mechanisms together. This game challenge involves a lot of different aspects and abilities that the robot has to be able to do to maneuver different defenses, to shoot goals. So trying to incorporate those all into one, or as least amount of mechanisms as possible in order to keep the robot as simple as possible, will definitely be the biggest challenge.
It is important that each idea is worked out to find the optimal concept for what we need to do. Then we go to the drawing board to figure out prototype designs, test and analyze what options work the best, and then build them. Because of exams on Thursday and Friday, there was a break in our work week. Once we got to the weekend, students worked to turn their drawings to real prototypes, using scrap materials and quickly manufactured temporary parts. By doing this, team members can see the effectiveness of their designs and make necessary changes. Thanks for joining us for this summary of the first week of build season. Tune in next week for Team 537's Robo Recap.